We're starting about now, are we?
Supposedly.
Okay. This is going to be the TSVWG working group. Please don't leave if you think you want another group, because this group will be good and fun.
Okay.
Can you hear me? Well, heck, why not? I have ways and means of making this work. I found an on button.
It's working too. Good.
Yes. Okay. I can walk around with this. We are organizing the second of the TSVWG meeting slots. It's the transport area working group. We have an agenda uploaded. We have a note taker over here, and a backup note taker is perhaps, okay, we have a primary note taker, that's okay. We will need a JavaScribe, partly because one of our working group chairs, you will notice, is not here. So could somebody volunteer as a JavaScribe, please? Over there, Chris. Okay. David, do you want to see if your mic works?
Okay, so we'll talk about the agenda here briefly. Here's the note well reminder. We have three major items for the agenda today. We're going to start with the L4S drafts, looking at goal of this meeting is to figure out where we are in terms of readiness of those drafts working group last call. There'll be a number of presentations here. What's on this slide may not be exactly what we do in terms of slide decks, although Bob wins a prize because he's almost first up. And let's see, the just-in-time slide metric, I think, was under 10 minutes this time. The some congestion experienced is second major item we do today, and then we are going to try to leave some time down at the end for discussion of some proposed new work on DCCP multipath. As we get started here, we're going to explain exactly what we're going to do on how we're going to conduct the L4S discussion. Anybody want to bash the agenda? We will be enforcing some cutoffs. In particular, I'm quite certain we could spend this entire session and probably until 4 o'clock today discussing everything there is about L4S. That's not going to happen. There will be a time cutoff. I'm going to apologize in advance to people who are going to get cut off at the mic lines based on what I think is about what we think is about to happen. But we are going to make sure that there is time for the SCE presentation today, and we are hoping to get to DCCP multipath. Okay, let me go see. Gotta go.
This man is David Black, in case you don't know him, and I'm Gory Fairhurst. Where's Eddie, as we said, is remote.
Push enough of the right buttons when we get the right size up. Just when I need them, it's not going for it. Yeah, it's. Okay. Now, unfortunately, we got to the wrong page there. What I need is materials. Give it a minute, okay? Does anybody know the magic open a new tab sequence on a Chromebook? Sorry, what? Control what?
Control T.
Control Tango. All right, let's try that. All right.
I can start anyway, can't I?
Go ahead and start the script.
Okay, so
Go get the IPR slides.
I shall tell you a little bit how we're going to run the L4S part of the discussion today. This part will start with a quick review of the IPR discussion that we've seen on the list. I shall say before anything else is said, this is what the chairs see of the IPR staring down at the mailing list. If you have IPR concerns, please read the IPR associated with the documents in the tracker, and please consult people who understand IPR concerning the way in which you view IPR. We will not make a determination, but we would like to summarize. After summarizing, Bob will present the current status of the drafts, which have been asked to go to working group last call. These drafts were brought to the working group, I think, in 2016 in Buenos Aires, if you remember Buenos Aires. And they were adopted in Prague. So, what? Thank you for the detail. Adopted in Prague, and now we consider that it might be an appropriate time for this working group to ask, are these documents ready for a working group last call? We need to have a working group last call to judge consensus. We need to have a working group last call to judge technical issues. Only when the documents complete a working group last call will we consider progressing them, and documents can go through multiple working group last calls or simply be returned to the working group after that process. So in no way does this terminate the process, but it's the beginning of the end of a process.
Or perhaps at least the end to the beginning. Absolutely. Okay, so there's been some recent discussion on the list and offline about IPR discussion. I'm going to quick summarize that, but I first need to put in a disclaimer. Your working group chairs are not lawyers. This slide deck does not contain legal advice. If you want legal advice, you need to talk to a lawyer. Your chairs, the IETF, disclaim all responsibility for any legal consequences of using the information in this slide in these slides to make decisions that involve legal matters. Okay. All right, hang on a minute. Oh, hang on a minute. It should be okay. No, I do. But if I hit the right button here, it also works. Okay, so the history of IPR discussion is a TOC raised concerns over some defensive suspension clauses in the Alcatel-Lucent IPR declarations. Broad conditions. It was unclear whether the declarations superseded the previous FRAND terms in a previous IPR note. This has been resolved. Both of them apparently still apply. We summarized the discussion that was on the list. You'll need to go for the details. There's a link in the slide deck where you can go find that. The terms that we saw in those IPR declarations were similar to terms that we've seen in other IETF IPR declarations. That's not a statement about good, bad, right, or wrong. It's simply a factual statement that there is similarity. Okay, relationship of IPR to the draft. The AQM coupled dual Q draft is a framework for coupling AQMs with non-normative implementation appendices. Bob Briscoe, who's been heavily involved in this, posted his analysis to the list. Quote, key quote excerpted from that is the claims all cover non-essential and non-preferred aspects of AQM dual Q coupled. We've got a list here of alternative implementations of AQM dual Q coupled. You can find Pi 2 described in Appendix A of the draft, Curvy Red described in Appendix B. There's been discussion in the working group that's made it pretty clear that FQ could be used to do this, and there may be others. All this is just to be provided as As information, every participant needs to make up their own mind about applicability or lack thereof of the patents to the drafts we're talking about, and level of concern to be placed on the IPR, the contents of the IPR notices from Alcatel-Lucent. Any questions? Oh, I love seeing empty mic lines after legal nonsense. Hang on. All right. Okay. With that, I think Bob is up. Bob, okay. You'll need to think about how, let's see, how many slides do you have here? 21, okay. Yeah, please make good use of the time, because yes, we need all the background, but we need to spend the time on discussion.
Yep. Okay. Yeah, it's about these three drafts. Have I got a pointer? Or?
This should work, we think.
Okay.
Try that. Let me know if it works.
Yep.
Bingo.
Right. So I'm going to take a bit longer to explain L4S background, because the sort of heat around this debate may have encouraged some other people to get interested. So the motivation for L4S is ultra-low queuing delay for all internet applications, with the emphasis on all. The idea being that by changing TCP, that's the problem. So it includes capacity seeking. And the sort of performance we can get is something like 100, 200 microseconds over the internet at the median queue delay, as you see there, the 50. This plot is a plot of queue delay on the horizontal axis in milliseconds, if you can't see that, and log of the percentile on the vertical scale. It's called a cumulative distribution function. And the tail is important. This is the real message for this slide, that for particularly real-time delivery, you need the higher percentiles to not have high delay. Otherwise, most real-time software will buffer enough to be able to pick up that tail. And so getting the tail down to, in this case, 8 milliseconds at the 5 nines percentile is important. Probably wouldn't buffer to 5 nines. You'd probably buffer to 3 nines or 2 nines, something like that, and just lose the rest. The other interesting thing that's important about this slide is, well, there are two more interesting things. Firstly, this is with really hammering the link. There's two queues here, and there's 300 web sessions per second hitting this link in each queue. So 600 web sessions per second with a range of file sizes and all the rest of it. Details are all there. I'm not going to read them out. And the other main point is that it's data center TCP, or what's now called TCP Prague, but this was done with the data center TCP, that gives you the benefit. It's really the end system that gives you the benefit, not the queue. All the queue has to do is have a ECN marking threshold for the end system to bounce off, if you like, right? And as you can see, that it's the blue one is the one from data center TCP. So it's about an order of magnitude at every percentile, and that's the trick. It's because it's got smaller saw teeth, so you can have both lower delay in the queue, less variance in the queue, and still full utilization. Right, moving on to coexistence, which is going to be a theme throughout. The problem is that because of those smaller saw teeth, it's more aggressive. And so one solution is to use the dual queue coupled AQM, and that allows you to do this without flow inspection. It has two queues, and they're coupled together in such a way that there's a squaring in the congestion coupling that means that the L4S marking is more aggressive to counterbalance the more aggressive congestion control. You can see the P versus 1 over P. Sorry, I'll get the laser pointer, which I guess I don't know which one to point at. I'll point at this one. The P versus P squared there, and the 1 over P versus root P. Right. Next, we've added this in to the slide deck. It's always been possible, and that is to use an FQ system for coexistence to solve the coexistence problem. So FQ XXX, where XXX might be coddle, pi, whatever. So if you want to do L4S in an FQ XXX system, it's a simple patch. Put if ECT1, mark with a shallow threshold or a ramp. Eric Dimazet put this code into FQ coddle quite early on. And then you base your marking on the immediate queue, not on the stateful thing that's going on in coddle or pi or whatever that's for the classic traffic. Eric, by the way, didn't do it on if ECT1, he did it just on if ECT. But it's a simple thing to do it just based on ECT1. And we've added a description of that into the L4S architecture document. Right, so that's the end of the recap. Implementation status, gradually getting more and more implementations. The transport protocols, I'm not going to read this all out, you can read it in your own time. Just highlight that BBRV2 has been added to that, as well as, and TCP prog has been updated. I'm going to give more detail on that. By the way, you gave me 15 minutes and 5 minutes, and the 5 minutes is sort of subsumed in these slides, if you like. Right.
Yeah, in addition, we got through our piece faster, so
yep.
Keep going.
Right. There's some components of the transports that are generic across them all and can be used for other things. Particularly, you'll note there we've now got a FreeBSD version of Accurate ECN from Richard Scheffenegger. An ongoing work on the startup with paste chirping, and also a lot of progress on subpacket window. I'll come on to that. Progress in the cable industry on chipset implementations for cable modems and CMTSs, with talk of products later this year, in the sort of autumn time frame. The dual queue coupled AQM, we're trying to get that into the main line of Linux. It's been submitted once and going for it again very shortly, hopefully. And the Linux patch for FQ, L4S FQ coddle I talked about. Not going to go through this. This is just a list of links so you can find the code for those things from the previous slide that are open source. They're not all open source on the previous slide, but there's a link. No, there isn't. I'll come to that. There's a home page. Andrew? Right. Just a brief report back on the hackathon. Oh, sorry, Andrew.
I just wanted to ask, are you aware of anybody working on putting L4S support into the special QDisc that is used at the bottom level of the Linux Wi-Fi stack?
You'll need to get closer to the mic.
Sorry, Andrew McGregor. Are you aware of anyone working on putting L4S support into the special QDisc that lives at the bottom of the Linux Wi-Fi stack? Because you can't put a normal QDisc on a Wi-Fi interface in Linux anymore.
I'm not aware of anyone doing that, no, yet. But if you're interested, I'd love to talk to you. Are you interested?
I'm not sure I have time, and I'm pretty sure that the other person, what the other of the 4 or 5 people who could do it, who's sitting in the room, doesn't have time either, do you, Tim?
Right. Okay. Oh, you're not coming to the mic. Okay. So, report from the hackathon. Kuhn brought a test bed over from on the flight, and also the SCE team brought their test bed over. We put the two together. So the big highlight of this hackathon was 2 teams working together on this. in a professional way, I should add. Thank you very much. Right, and managed to get some Flint regression tests done. That is running regression tests on tests that Jonathan specified to see whether putting L4S in there made any difference. And as far as we got, it didn't make any difference, that is. L4S didn't make any difference. So that's having an L4S node before an FQ-CODL node and in various orders. But a lot of problems with the Linux kernel during that hackathon. I won't go into any more details due to lack of time. As I said, Richard Scheffenegger did a FreeBSD accurate ECN implementation. Michael, I should add, was not involved in the implementation. He was there as the sort of gatekeeper of FreeBSD to make sure Richard didn't do anything silly. We had our first accurate ECN interop over the internet between Linux and FreeBSD. So two working together, they both had the same bugs.
That presumably makes them easier to fix.
Yeah, no, precisely. They both had got bored reading the spec at the same point, so it still interworked. Right. Some talk about the subpacket window, and also paste chirping was integrated into the NS3 implementation. That's still not open, but hopefully very shortly. But I have said that before. Right. You wanted a bit more detail on TCP prog pieces. This is an update of a slide I presented at ICCRG in March. There's a few differences on it, but the main thing I want to highlight is obviously the TCP prog column. But this also shows that some parts of it, or quite a few parts of it, the majority of parts of it are actually in base TCP, not in the congestion control module. And it's sort of reusing parts that people are doing for other things. I guess the obvious thing to that people focus on is the stuff that isn't green. And we have now got a working implementation of scaling down to a window below 2 and below 1, and in fact got to 0.2 of a packet, so pacing down over 5 round trip times, and this is going at 300 microsecond round trip time, so that you can actually not just build up a queue in order to do that. That's more for data center work. And been talking more about RTT independence, but haven't done any more on it in terms of implementation. Then the big open issue, which I'm going to talk about, is Reno friendly if there's a classic ETM bottleneck, and I've got a slide on that. Right, a couple of slides on recent developments. The dual pi squared implementation has largely been unchanged for quite years now, but we've been changing the scheduler over to weighted round robin, and also we've put a management shim, if you like, on top of the parameters, so that you can put in 2 human understandable parameters, the typical round trip time and the max round trip time, and it will calculate all the sort of proportional integral controller parameters for you. And the maths is in the internet draft on how it does that in pseudocode. But I should emphasize that for the internet, it's zero config. You know, this is for if you were having to reconfigure it for some different scenario, but the defaults work just fine for the internet. The second recent development, other than all the other stuff going on, is posted a new draft documenting the DOCSIS queue protection function. That's not intended for consensus at the IETF, it's just saying what DOCSIS did, so that it's openly available in the IETF. And the emboldened phrase there is the most important bit. There's an objective definition of what your flow behavior has to be in order to avoid being rejected as you go into a DOCSIS link. So what's the sort of maximum aggression that you can still get into the low latency queue. So just to emphasize, it's not one of the core L4S drafts. It's not even a TSVWG draft. It'll probably go into the independent stream. Well, it's been not accepted, but it's in the queue to be accepted, right? And that the overload protection that's in the dual queue draft would be a sufficient alternative, but this is per flow, the queue protection function. So it kicks out particularly ill-behaved flows, but you have got a sort of bulk overload protection as a basis. And it's really, I guess, part of the L4S experiment to see whether it's necessary to have per flow protection, much as I suppose you could say the internet experiment has determined whether we need per flow rate control for the voluntary compliance with TCP friendliness. You know, it's sort of, that has determined that we don't really need per flow rate control. The L4S experiment will determine whether we need per flow latency protection or not, or whether the inherent incentives for yourself are sufficient to that you don't want to ruin your own latency. But this is obviously more for accidents and malice. Right. I won't go into how the algorithm works because we're short of time, because I want to get onto these issues. Right, a little bit of history about the #1 open issue, I believe, RC 3168 ECN in a FIFO. So if you have an AQM that behaves like RC 3168 says, and you're in a shared queue, and DCTCP or TCP prog or quick prog or whatever competes with existing TCP friendly traffic, is the world going to collapse? And the history of this, we chose the ECT1 code point back in 2016, knowing full well this could be a problem, thinking that it may not be a problem because all the academic studies had showed that there was no deployment of such routers, or we thought they showed that. Then, in fact, only a few months later, Padma Boomer at Apple did a study, published a study in MapRG, which the slide, the black part of the slide there shows, where there was CE on the internet. At the time, sort of dismissed it as probably FQ coddle, but the controversy around this has made us think, well, yeah, actually that is not a very scientific assumption. We ought to check that. So sort of the greys have not come out on this. There's dark grey and light grey on this, but never mind. Does it come out?
We're on this one.
Oh yeah, they come out on that one. Yep. As I said, what if that assumption is unsound? And really, we're currently at an uncertain state. In the left-hand bubble there are a couple of CDNs who are doing testing, looking for these CEs. They have been found. I'm not going to identify who they are. I didn't actually ask whether it was okay to identify who they are, but so I'm not going to say. I'm also not sure whether even when they get results they'll be able to tell us, or even tell anyone. But unfortunately, layer 13 comes after layer 4. You have to get the results before the lawyers will ask, accept questions on whether you're allowed to release them. And so we have devised a test on how to look for these routers once we get the results of the tests, if we get the results. So that's the sort of ground truth side of it, what is on the internet at the moment. Then so that's more like prevalence. And then the quantify flow imbalance is more like the harm. In other words, the risk is a combination of how much of it is there and how harmful is it when it is there. And so the next slide, we've got some measurements on how harmful it would be when these flows join each other in a single queue. Jake.
Hi, Jake Holland. Just wanted to self-identify. Akamai has been running a few tests with ECN on the internet, and we have observed ECEs in the wild.
Yep.
We are not sure where they're coming from. We're still looking at it. I hope maybe one day, if I have time, to present something in MapRG about it, but we have not proceeded to that point yet. Thank you.
Yeah.
So Jake, it's a bit hard to hear up here, but are you saying that you see some ECN mark traffic?
Yes.
Okay.
We've seen specifically what I was looking for on the download was the echo response, right? So we have some production traffic being served with ECN enabled, and on those devices that we put up, I was looking to replicate the Apple results with Argentina and France. It's hard to tell whether flows that do not see an ECE are uncongested or don't have an AQM in path. But we do see all of the servers that we put up do see some wild ECE marks.
Thank you.
Rod Grimes. If there are any operators or other people in the floor that could help Bob or myself get some of this data, we are both very interested in that. And I'm just reaching out to, if anybody knows any place that would be willing to help collect some of this. It's very valuable.
Yeah. And actually the other CDN did do some digging. Well, actually, I think I can say this because yeah, there is some other data here from Apple's original study, and that Argentine Republic 30% CE marking. By the way, that's 30% of devices saw at least one CE mark in 12 hours. That's not 30% marking, right? Yeah. Apple did do some digging into that and identified the ISP involved, and we are trying to get hold of the people to see whether that is like a FQ-CODL deployment or, or whatever it is. And similarly, the reason we're going for CDNs is we're looking for, it's more likely that single queue AQMs are in the downstream, whereas FQ-CODL is more likely to be in the upstream. However, Cake is also in the downstream at the other end of the access link, pinching off the access, and that would be potentially causing CE and echoes back that Jake may be seeing, but we don't know where these CEs are coming from. So there's more work to be done. And just before I go to the next slide, about the level of harm this would cause, the idea of this is that once you've got the prevalence and the level of harm, you've got an assessment of the risk. And so I'm sort of laying out a process that we've then got a spread of possible scenarios. If there's a high risk, then definitely we'll put some code into, all the star Prague L4S code to try and measure this, and it's going to be difficult. We'll get false negatives and positives and all the rest of it.
Oh, it's just trans. But Bob, when you say there's a risk and you need new code, is that a change to the 3 specs which are on the table, or is that a future spec for the transport?
The specs currently assume the high-risk case.
Yes.
But we haven't done it in the code. Yeah.
Okay.
Yeah.
That seems a reasonable experiment to go forward. Carry on.
If we don't find much and the harm, if it were found or if it were added in the future to the internet, is relatively low, then possibly sufficient would be to put advice in the L4S drafts to say, do not or limit this experiment over your network, e.g. by disabling on CDN ports that are going into your network. Do not put L4S traffic from a CDN into your network, particularly if you're, the end of that sentence is if you know you've deployed RFC 3168 AQMs in your network. Obviously, if it's Cake and FQ-CODL, that's going to be safe because they're in per flow queues, so they're not going to overrun them. Right. So these are the results we've got for a range of link rates along the bottom, 4 to 200 meg, and within each link rate, a range of round trip times, for the unfairness between DC-TCP and ECN cubic in the dual pi. Well, it says the dual pi squared L4S, but they're both in the pi squared AQM. They're both in as if it's a classic AQM. They're not using the LQ. Right? We marked the DC-TCP traffic with ECT0 to put it in the other queue. So the worst case there is about something like that middle one. Where are we? Whoops, sorry. That was not very useful, was it? I pressed the wrong button. There. The worst case there between that one and that one, I think, is about 20, but in most cases it's about 10 along here, and it gets the sort of good news, if there is any good news in this slide, is that in a severely congested environment, they get close to 50-50 at low link rates and low round trip times. So I'll let you digest that in your own time. I should add, I put on the list this morning a copy of a paper where preparing for a journal with a whole load of performance measurements for L4S across all these link rates and round trip times, and with different traffic models, with different congestion controls and all the rest of it. And I sort of attached it to the end of a paper so that because the paper describes all the experimental scenarios, and the original paper just had a selection of the plots, but what we've done, we've put all the plots, just stuffed them on the end of the paper. So you know, we can't be accused of selecting results, if you like. You know, whereas when you put in a journal paper, of course, you can select results. And I'd like to see results like that. So we always show not just queue delay, we show utilization, queue delay, drop, rate fairness, etc., because you can always focus on the good part of any one experiment. You know. Right. Okay. So there's the loss detection issue, which is of particular concern to David. How much time are we on the limit? Or?
If you could finish up in the next 5 minutes, okay, that would be good in particular. I think at least discussion is open issue number 2 probably ought to go to the main discussion as opposed to be done while you're up here with slides. So I would present what your view of this is, and then we'll pick it up.
I'll just set the scene for the discussion later. Yeah. So there are objections to this requirement that an L4S source also has to measure or detect loss in units of time, and at the moment it's a must. We have discussed a way to change the ordering, to change the wording. There are 3 real objections to this same requirement. One is particularly David's objection that it could be interpreted as a prohibition of using 3-loop-back in an environment where you don't need to do this anyway, because you've got a link technology that doesn't reorder stuff. And so I'm sure we can deal with that with wording. The other is an architectural concern that it overloads one code point with 2 meanings, and those 2 meanings being low queuing delay and low resequencing delay. And then really the argument against that I would make is that, yes, that is strictly 2 different meanings, but they're both low delay, and what would be the value of finding 2 identifiers for those things? You know, it's sort of worth conflating them. And I've put a bit of discussion on the list about the possibility you might ever have a case where you wanted one and not the other, you know, if you were short of memory for the resequencing or something like that. And that discussion, I'm sure, might continue. And then there's an objection primarily from Michael Schaaf that one experiment shouldn't depend on another. And the underlying concern here is to avoid having a potentially successful experiment depending on a potentially failed experiment. And bringing down the dependent one. That's not such a concern here, because if rack fails, and that's unlikely given it's widely deployed already, this aspect of L4S can be relaxed. L4S doesn't like completely depend on this requirement. No, it's just we can relax that, and we can talk about that. And also, it's not a dependency in a formal normative sense. It's not a normative reference to the rack draft. It's a dependency on the idea behind rack. Next slide. Right. We are willing to consider a should instead of a must for this requirement, and maybe warn what would happen if you didn't do it. And so we can have that discussion. You know, that's for the discussion
Working group
later.
decides.
Yeah. And then just not going to read all this. This is all the drafts that have been updated in the last cycle, and the new one, the Queue Protection one, and an adopted one in NSH. So as you can see, quite a lot of ASCII writing going on, as well as code writing. You might write your code in ASCII, I suppose.
Tis common.
And that's it.
Okay.
Thank you.
Right.
Did I get in time?
We're short of time, but we're okay for time.
Right.
So. Okay, so what I think now I'd like to do is offer a bit of time to talk about these drafts. It's sometimes the case in the IETF that the mailing list explodes with ideas and thoughts about what we've been doing just before working group last call. And it's sometimes that the mailing list dies out and you can hardly trace what's going on when we get to a working group last call. This case, quite a bit's been going on. So let's use a little bit of time to try and talk through the different things. We made a list as chairs of things that we thought we saw. This may be a totally useless list, but we're going to show it anyway because it may help some other people. And if your comment directly matches one of these, or we want to come back to it, then please say so. But generally, let's have a discussion about these drafts, particularly relating to whether there are significant issues remaining or things that should be clarified at this stage before we hum on whether to pass them to the working group last call status. So, who is going to be first? Jake. Your cue's shorter.
All right, great. Jake Holland. I would add one item to this list, which I was thinking. I would add one item to this list, which is admission control for untrusted marking on the classifier.
Admission control on the classifier. Yep. Okay. The AQM recommendations state this as research currently, as something that we should be thinking about how to control floors not obeying with the traffic contract there the scheduler is expecting. And what would you suggest we do in this space? We have a document that was put forward by Bob, which in his slide deck, which I'd very much appreciate, which is revealing what one of the operators is trying to do right now, but that's an information on what they're doing. Do you think we should be doing some working group work on this?
That is an interesting question. I just would like to see it. I don't have an opinion on that at the moment. I just would like to see it added to the list as a concern that has an impact on the congestion control aspects of this. Thank you.
Noted. Thank you. Christian?
Yeah, it's something about the evaluation of the L4S experiment. I have noticed that Bob's slides always present comparison of L4S against Cubic, which is not designed to minimize end-to-end delays. I would very much like to see comparison of L4S against delay-based congestion control algorithm, such as BBR.
Presumably BBR v2 rather than v1.
Yes, yeah. The general idea is compared to congestion control algorithms that are specifically designed to minimize delay by opposition to those that are not.
This is Bob Briscoe. That is the question. If you try and compare with BBRV1, things like your rate fairness, it's not you that's the problem, as you've pointed out. And so we're waiting for BBRV2 now to come out. We can start to be able to do that, but that's why it's not appeared. It's not
any other. Jonathan Morton. I have...
Please get very close to the mic because the chairs can't hear.
Okay, is that better? Okay, so I have 4 different topics to bring up that are closely related. Points A, B, F, and G. Yeah, so Jonathan Morton. Okay, so on point F, ISO 8311 states that IETF approval is required for experiments involving congestion response differences and congestion marking differences, as these could involve effective redefinitions of the CE and ECT1 code points. In other words, ISO 8311 does not itself modify ISO 3168 to permit these behaviors that L4S desires. On point G, on incremental deployment, this obviously requires compatibility with ISO 3168 compliant AQMs. This has not been demonstrated, and there are serious theoretical concerns which we have validated by experiment as of last night, which of course speaks to point A. ISO 8311 states very clearly that effective congestion control is required. With CODEL now being the most deployed AQM, the default parameters of CODEL and the relatively low latencies that L4S targets, we found that with a 10 millisecond RTT path, a simulated TCP PARC flow would require 4 seconds for CODEL on its default parameters to reach a controlling marking rate.
Are we clear that this is not FQ CODEL but pure CODEL? Yes?
This is the CODEL algorithm itself, acting on a single flow. And if multiple L4S flows were going through a single queue controlled by CODEL, then the time required to reach the correct marking rate would be similarly multiplied. So
I'm just need to clarify. Are we talking about widespread deployment of CODEL without fair queue?
I'm talking about widespread deployment of CODEL in total. If we include FQ CODEL, then it is extremely widely deployed now, because it's default in most Linux and Mac OS X devices.
Okay.
I think we can agree that taking 4 seconds to control the congestion induced by a 10 millisecond RTT flow is not effective congestion control. Now, moving on to point B, fair queuing, AQM, is pretty robust. By itself, introducing fair queuing would be reasonably effective, I think, but there is still a concern where you have 2 consecutive bottlenecks, as presently occurs quite frequently when you have a last mile link that's controlled by a DOM FIFO followed by a consumer equipment box, which is implementing FQCODL or something similar. And from our experiments, we have found that you can have quite a large delay spike induced in the DOM FIFO until the AQM downstream is able to control it. So again, this comes back to our 4 seconds to control it. That's 4 seconds of persistent queuing in the last mile link.
It does sound like FQCODL may have issues that need to be looked at.
Mm. I think that's all I have to talk about at the moment.
Okay. Does anybody have... this can be a discussion people can follow up if they wish. But yes, next in line.
Yes, my name is Peter Heist. I'm with the SCE team also. I'd like to raise 2 concerns we have. One is to highlight topic E. We have a strong concern about using ECT1 as a global classifier. RFC 2474, which is the DSCP RFC section 7, the security section, talks about how DSCP relies on its DS domains for its security. It relies on protection at the borders as well as the integrity of the domain itself. So with using ECT1 as a global classifier, there are no domains. So we'd like to highlight that concern.
Okay, this consensus to use this was agreed in Berlin in this group. We can look at it again.
Okay. And second and finally is topic H regarding the implementation status. What we didn't want to do is come and broadside the team with results that they haven't seen yet, so we won't do that. But what we will do is confirm that there are issues on the 5.x series kernels of the current repo where TCP prog is overreacting to CE marks, and we saw that in our test results. And we would also say that we want to make sure that the current code base is running on a 5.x series of kernel and not 3.19, so that we can be testing on a kernel that isn't EOL. So that we feel that that's very important for our testing. And lastly, we didn't get too much to our interop testing, but in the next few weeks, as L4S is reviewed, we hope to do that. That's it. That's all.
Okay.
David Black speaking from the floor as an individual. As Bob sort of hinted, this concerns open issue number 2, which on the slides is C and D, and I'm going to take in reverse order. The whole point of the single, and so I'm definitely speaking as an individual on this, the whole point of the L4S experiment is to go look at something that is an experiment for the internet as a whole. And from what you've heard from previous speakers, the interaction between flows that L4S is trying to address can occur in any queue anywhere in the internet. So internet scope of that experiment makes an enormous amount of sense. The resequencing tolerance I have been complaining about, and this will mark the 3rd IETF in a row where I continue to complain about lumping that in. It's been hard to understand what's going on. I want to thank some of the folks on the L4S team for helping enlighten me a little more here. What I believe is going on there is that there are certain link technologies where you're using RF signaling, particularly over wireless, where on a multi-channel or multi-bearer link, you get different loss rates, different bit error rates, things like FEC and retransmission come in, and if that hits the lanes asymmetrically, well, then all of a sudden you've got to wait for the slowest lane, and there's a resequencing buffer, and that induces delays. Now, if that understanding is correct, what's going on here? This is not an internet-wide problem. It does not happen in data centers. We have experience in my company in looking at data center optical plant, where we gave up testing for bit error rates at 10 to the minus 18 because the errors just weren't happening and we had better things to do with the equipment. Needless to say, the underlying cause of the resequencing effect is not there in that class of networks. I believe what's going on with the resequencing is it's not your net-wide. It's specific link technologies in specific networks, mostly access networks, and ought to be solved with some kind of network-specific approach as opposed to lumping this into one experiment where the goal is going to be we're going to get everybody in the internet to adapt all their endpoints to deal with these link technology specific and network technology specific problems. I believe that latter approach is a major mistake.
David's topic was raised by the chairs and a number of previous things, saying if this is the intention, then we need cross-area review before we can proceed. Does Bob want to speak about the text? The text we're talking about is in an appendix. Bob, do you want to clarify whether the intention is to deal with reordering or the reordering is a future vision that can happen because you do this?
The latter, definitely. And I also want to make it clear that I've heard David say this a number of times, and maybe something just clicked in my head as to something that David hasn't picked up on, that what we're saying is that when a link has the capability and the possibility of not doing resequencing on packets with the identifier that says they're L4S, not with packets from all end systems. Is that understood?
I understand that. This is proposed as an internet-wide service that would presumably be rolled out to and be of interest to a large population of end systems. Yes, I understand that you can't get in trouble if you didn't set the code point that says go ahead and omit resequencing. But I still believe that this still has a major scope problem, and it's not the same experiment.
Right, because then, given that relaxation is only for packets with the ECT1 code point, the relaxation for the links, the sources that this requirement is requiring to do this loss detection in time have to be modified in order to change their congestion control to set the ECT1 anyway. So, that's why we've said there's an opportunity here to use a time-based loss detection, which happens to be deployed in across TCP versions now in Windows, FreeBSD, Linux, and all the rest of it in rack. So there isn't, it seems like a good opportunity. That's the rationale anyway, and we can have the discussion on the list maybe, back and forth.
I think you're about to have a glass half empty versus glass half full discussion. I see the opportunity. I view it as an opportunity for a separate experiment, not one that ought to be lumped into the L4S experiment.
I concur with David's view as chair that this is a different experiment to the one we originally charted, and I'm not sure that it's a required experiment that has to go with this. And if we do it, then we must go to Interia and we must talk to them about the implications on Interia and RAI. So do we need to unpack this here as part of the L4S bundle? And this is a thing we should talk about today.
The L4S drafts just say the source should measure loss detection, detect loss in time units. It doesn't say anything about what links must do. So that, in that sense, it's not saying this is a link experiment, but it's saying that someone else could do that experiment with L4S traffic.
It's in an annex to the spec currently. Yeah. Does it need to be there? It
doesn't need to be there, no. All it says at the moment in the annex is that links could do this. It doesn't say may in any normative sense, or should, or anything like that. It just says they could.
I suspect part of this is also will come out with time. If we see quick, widely deployed with PTO-based detection and rack widely deployed that does timer-based thing, we will maybe see a general reduction of the reordering requirement in the internet. But that is a philosophical debate about what might happen in the future rather than what has to be in the spec.
And the point here was to say, if a link sees a packet with the L4S identifier, it knows that it's got that behavior rather than there's some fuzzy possibility that it might have it.
Yeah, unfortunately, the moment you say knows, you've lumped the two experiments together.
No, you haven't. You've just, we're not saying do that experiment at all. We're just saying we're opening up the possibility for someone else to do it later. It's not. Sorry, is that funny?
Jake's in line. Are you on this topic, Jake? Okay.
Okay, I'm not sure there's much else to add there. I guess I could ask one question that might give us part of a path forward. Bob, is that annex part and parcel of the draft, and hence the annex is experimental because the draft's experimental, or was the annex intended to have a different status with respect to the rest of the draft?
Well, the annex is informative.
Okay, so let me suggest one possibility that would make me happier. Although I'm still not going to, I don't know if I can satisfy. What if we pulled that annex, and I think there's another couple of informative annexes, out of that L4S draft, put them in a second draft that is very clearly marked as informative, and that there will be no normative reference from the L4S draft without the annexes to this new informative draft?
I can take it out completely. You know, we don't have to say that links could do this.
The issue is not so much what the links could do this. The transport protocol must have this behavior to participate in the experiment.
Right.
It's that text.
No, that part is in the normative part of the spec. Okay. And then in the annex it says what links could do but what I suggested in the talk is we could make that must into a should.
I would suggest you consider removing the paragraphs, resubmitting them if you want to later, but avoiding making any statement about the reordering apart from what's actually happens when you use L4S, maybe concerning the CE, whatever. That bit is fine. Speculating the future in that affects another area is a much trickier thing to put in an EXP draft.
Okay, I have to rethink this then, because there's a lot of people that really like that aspect of it.
There are.
You know.
And there are a lot of people across the IETF who like that. And there are a lot of people who also maybe don't like it. But this could be the document that tests that, if you wish. Our advice is, let's think carefully.
I guess I would characterize it as there's a lot of people who like it technically, and there's a lot of people who dislike it procedurally.
If you think people like it, write it in a separate draft, I think. Anyway, okay, back to Jake.
Hi, yeah. So, Jake Holland, this list is, as I see it, a list of the technical considerations. I think there's, and I agree, these are, the more important aspect of this. There's one other sort of set of issues that I would characterize as editorial considerations. I raised a point on the list recently, so I don't know if you want that in this list also. The list of potential issues with regard to advancing the draft. I only have an individual hat, of course, and it's I don't know whether I'm being too picky. But in terms of the sort of goals as stated by the RFC editor, in my opinion, there were some significant editorial issues worth addressing before moving the drafts forward. So I would also request adding that to the list, although I would, if you want that characterized separately as a non-technical issue, that's fine.
Okay, Jake, let me just be sure what you mean by editorial. Do you mean that sections shouldn't be in a particular order or text needs to be corrected, or do you mean that sections should not be in a document?
No, this refers more to word choice, characterization of
Excellent. I can immediately respond to that. This is excellent feedback. There's a sad thing about IETF process that we don't get people often sending those comments in as the documents progress through the working group, and they're very much appreciated by the authors and the chairs. At working group last call, it is an exceedingly good time to make sure that all the words are as good as we can make them. RFC editor will tidy up and will fix, but it's our job to get the drafts as best prepared as possible. So yes, please send those to the list.
I sent one section review to the list. I was waiting for some feedback. There's been a lot of traffic on the list, so I understand there may be some delay. I was waiting for some feedback and sort of other opinions on whether this is a useful contribution or whether there's some sort of, because I believe if I continue on the path I've started, it will be quite a lot of feedback.
Bob's going to the mic.
Hi, Jake. I suspect this is one of the emails I've started and not finished, and I think I've sent to you, but I haven't. But yeah, I've accepted. And I've also said you don't need to go through the rest of the draft pointing out stuff. I can do that. That's my job. You know, I've got the idea of what you don't like. Yeah. Okay.
Likewise, just because I don't like it doesn't necessarily mean it. You know, it's a question of consensus. But I wanted to raise the issues, and I hope it's been helpful.
Would you rather I said what you obviously don't want to say, that it's basically too hypey?
Sorry.
There's too much hype in it. You know. Yeah.
Yeah, that's the general nature of the feedback. Yep.
Yeah, please reduce the hype, or else either your working group chairs will tell you to do so, or your AD will tell you to do so. But for sure, it won't make its way through the full process. But this is normal. This is part of preparing a document for actual standards. Okay, so. Any more questions?
In that case, I think it's time for a hum. I get to put my working group chair hat back on, so we've got 2 more ears to listen and judge.
Please come and join me, because if we start asking questions, I want to know the answers that are given. First of all, could you indicate to me, all right, we have 3 drafts. Do we have a list of the 3 drafts somewhere? Yeah, we will figure out. We're going to do hums first. It's okay.
We will be doing hums, and at least I'm going to be down, walking around the floor, trying to listen.
Okay. So first thing is, I'd like a list of drafts up, and I'm going to ask who's read the current version or a recent version of these 3 drafts. So the 3 drafts are listed here. So let's go for L4S architecture. Could you please raise your hand if you'd read this version or a recent version of this document? Could somebody tell me how many people have got hands up? It looks like quite a large number. Okay, more than 20?
At least 15, approximately.
15 to 20. Okay, right. Guess what the next question is? Have you read the L4S ID? Please raise your hand if you've read the L4S ID. Slightly fewer than the architecture, maybe about 15. Okay, and the dual Q, the dual coupled AQM. Oh yeah. Okay, so we have maybe 15 to 20 there as well. So the first pronouncement from the chairs is that I believe we have sufficient number of people reading these documents that the working group can now consider what happens. Do we deal with them as a bundle? Oh, just a minute. Wes could comment if he needs to. Just a reminder to Wes as the document shepherd. Wes does want to comment. That's good.
Yeah. So one of the things I noticed is that we had 10 topics listed, and we came away with maybe one more very clear extra one and a couple of ones that I think are probably sub-bullets under the testing issues. But the one thing I actually noticed, I was keeping a score, and no one brought up topic J, which was the IPR. Do we want to do we want to assume that things are better with that now, or not?
Wes, this is David. I think some of the IPR stuff may need some soak time. So let's hope that this is a sign that it will not be playing a leading role in the future.
There's people at the mic.
Rod Grimes, I believe the people that would like to speak to that issue on the IPR are not present, and will probably speak on the list as that subject comes up.
And I know that Toke Holland-Jurgensen was planning to do so, but the timing is bad for him today. Sorry. I believe Toke Holland-Jurgensen was planning to talk about this today, but the timing was bad for him with this session. So he will probably comment later.
Yeah, and we already have some input from him, so more input will be welcome. Okay, Wes?
Yeah, that was really all from my summary. I thought it was good discussion.
Okay, so then in this case, I propose that we take the sense of the room using a hum to decide if we should put these documents into the working group last call for comments stage. This stage will open a formal process for people to comment on the documents. Please relate such comments as you think about whether you think they're ready, because if the comments you provide should be related to sections of these documents to see if they are ready and fit for progression by the working group. And we would like to know if you think those documents are ready for evaluation in a working group last call. Please hum if you think these documents should go to working group last call now. Please hum now if you think these documents should not go to working group last call now. Okay, so if you didn't hum either way and you wish to come and speak at the mic, please do. But first of all, I'll ask David what he feels the sense of the room was.
I heard weak hums for both alternatives.
There was also hums against in Java, but just from Dave. So there was also a hum in Java for against, but just from Dave.
Okay. I stare across the floor to see if our AD wishes to say anything.
Okay. Based on this, there seems to be some people at least that see it is not ready. So I think the reasonable thing here is to give those people a short time, a few weeks, to send those points what they consider is not ready, etc., and have a discussion on the main list to resolve that.
This sounds like a very good approach. We will not start a working group last call for this document at this IETF. We plan to do so, but we shall give a few weeks for people to respond to that plan and explain whether this is a good idea or not. So if you think that that plan is not a good idea, please explicitly comment on the mailing list to the chairs to help us decide what to do. And Magnus.
Yes, and I mean, if you have things that are technical reasons why it's not ready, ensure that that also gets raised.
Thank you.
All right. SCE, yes?
SCE shall be next. It's a non-working group draft coming around for presentation on this. Draft Morton TSVWG SCE. Please come and tell us about it.
There we go. Yes,
Right, is this working well enough? I think it... Okay. My name is Jonathan Morton. You've already heard me at the microphone. And I'd like to talk about some congestion experienced, an alternative proposal for the use of the ECT1 code point. So we would redefine ECT1 as some congestion experienced as a high fidelity congestion signal. And you can see the table at the top of this slide lists the 3 existing code points in use by IRS 3168 and the extra one. And we also use a spare bit, formerly known as NS, in the TCP header for feedback. And that's what our third draft is about. We retain all other IRS 3168 details for full backwards compatibility. And that means that if an SCE endpoint communicates with a non-SCE endpoint, it automatically falls back to standard behavior. If there's a non-SCE middle box, then we also have standard behavior. We have multiple instances of running code available.
Turn the clicker 180. That will help. And then,
oh, it's this way around.
Yeah. Sorry. Human factors get us every time. Okay. Here's again. You should go forward.
Okay. So our design philosophy is based on the 3 following quotes. Principles which are illustrated by these quotes. First, do no harm. Heterogeneity is inevitable and must be supported by design. Effective congestion control is required. So first for backwards compatibility, which is part of our do no harm and heterogeneity acceptance. Normal, additive increment and additive increase and multiplicative decrease principles apply. So we have a normal congestion window growth rate, a TCP-friendly response to loss and to TCP mark, and to congestion experience marks, and existing middle boxes treat packets that are marked with SCE as ECT and are still able to mark CE on them. Existing endpoints ignore our signals. This is completely harmless. It's a transparent fallback to standard behavior. The meaning of congestion experience is thus preserved. And that means that SCE becomes a soft cruise control signal, because we still have the ability to do a multiplicative decrease on a standard CE signal or a loss. If there's a big change, a big reduction in the path capacity. This is a big advantage over DC-TCP, which only has the one code point to do its signaling on, and therefore has to use, it still has to emulate the multiplicative decrease for that scenario. This gives us more flexibility in what we do with our response. And here we have a demonstration of what happens when we go through a standard middle box. These are two flows. Both endpoints happen to support SCE, but the cubic flow is not using the SCE signals. Only the Reno SCE flow is. And you can see that the two flows are proceeding approximately equal in throughput. And this is what you would expect from a Reno versus cubic comparison anyway. And the latency is also reasonable. There are spikes of up to 5 milliseconds added, which is, on an 80 millisecond path, that's very little. The way we apply SCE signals, and SCE is a signal from the network to the endpoints. The network boxes don't need to know anything other than it is an ECN-capable transport. So SCE is a high-fidelity congestion control signal which we apply as a marking ramp, a probability ramp based on queue surge end time, or queue occupancy if you prefer. High fidelity means that we have many marks per RTT, as opposed to standard marking, which is many RTTs per mark. Applying, of course, to the steady state situation. We can easily add SCE marking to an existing AQM algorithm, and that is what we have done for our reference implementation. And this is easiest to do if fair queuing is also implemented. We'll talk more about this later. A simple threshold function is a valid implementation. Ramp functions probably perform better. And CE marks are still relevant. You can see to the right of the diagram is the region above 5 milliseconds surge in time in which CODEL does its marking. So we have full backwards compatibility of an SCE middle box with existing RFC compliant flows. The response to SCE is signaled through ESCE, which is the former NS bit, which is released by the historical status non-sum specification. This is completely orthogonal to the ECE and CWR bits, which are still treated as with RS33168. And when this bit is set, it indicates that the currently ACT segment carried an SCE mark. The receiver logic is very simple, immediate, and almost stateless. So it's easy to implement. The patch in our implementation to do so is a few hundred lines, including some auxiliary things. It's simple. The sender response, it may ignore it, as existing implementations do. This is backwards compatibility. We have DC-TCP, which implements the DC-TCP response, but to an SCE signal instead of a CE signal, and it re-adds the ability to do a straight multiplicative decrease to a standard RFC 3168 signal. Reno SCE modifies this response to be less severe. We scale by the square root of the congestion window instead of by 2. We also have in progress a cubic SCE response, which also deals with the fact that cubic can grow at greater than linear rate. We exit slow start on a single SCE mark because we need to do that as soon as a congestion signal is received. And here we have a demonstration of an ideal scenario where cubic is competing with Reno SCE as before, but this time with a middle box that supports both fair queuing and SCE marking. And here we can see that the SCE flow in orange is neatly using the space, the capacity left over by the sawtooth in the cubic flow.
Mia Kulevin, just a quick question on the graph and also the other graph. For the cubic only flow, do you also have any AQM in the bottleneck?
Yes, the cubic flow is receiving CE marks.
And which AQM are you using in the bottleneck?
This is effective. We're using cake, so it's effectively Codel.
And the threshold, the marking threshold? Both of the marking thresholds, basically?
Standard parameters, 100 millisecond interval, 5 millisecond target.
Thank you.
So, you can see that there are no multiplicative decreases in the Reno SCE throughput chart. And this is because it is reacting sufficiently well to SCE marking to avoid the need for CE marks. The green trace at the bottom shows the latency of the SCE flow itself, and you can see that the peaks of it are lower than the purple trace, which is the cubic internal RTT.
That's with queuing, but ping in the same queue as the data, is that right? Or what? What was the ping?
The pink is the cubic internal latency, the flow latency.
Yeah, and you're using FQ?
We're using fair queuing.
And you've got a ping. Is the ping in a separate queue or in the same queue as something else?
The two flows get separate queues in this case. Because it's fair queuing. So the bottom flow right at the bottom,
yes,
in dark purple, is a separate measurement flow, which is using yet another queue.
Using a separate queue?
Yes.
So this is measuring how fast the queue is rotating, rather than the time through of the traffic, yes?
Yes.
Ah, right, okay. It's the scheduler ticks, yeah? Okay. Right.
So here we also have SCE's performance in a single queue with SCE support. And as before, we have a delayed startup of the second flow. So one has almost reached the link capacity, and the second must then compete, and we can see that it converges.
This looks just like FQ. I'm sorry, not speaking as chair here. Maybe I should go down there. But this looks just like FQ. I mean, this is just two queues, is it not? Or is there something I'm missing extra?
This one is single queue without fair queue.
Right, okay.
And you can see that from the caption on the right.
Yeah, yeah.
But this is with SCE, and you can see that with just the SCE response, we do have convergence. So we don't only support fair queuing. We prefer it, of course. However, questions were raised on the list about how we could do this with dual queues. And we observed that any traffic classifier, such as a DSCP, may be used to direct SCE traffic into a specialized queue. And so such that conventional traffic would default to the first queue. For robustness against misclassification, it is straightforward to arrange things so that the conventional queue does not mark with SCE, and therefore, if SCE traffic is misclassified into the conventional queue, then it just receives standard RSC 3168 behavior. And this, we think, is a major benefit of the unambiguous signaling provided by putting SCE on a different code point than CE. Now, if we put SCE and conventional traffic into a single queue, then as standard, SCE yields very politely to the conventional traffic. You can see the orange trace at the bottom shows much lower throughput than the cubic flow competing with it at the top. Now, this may actually be useful to some people if they want a scavenging transport. We leave that up to you. However, we have an alternative approach as well. By modifying the SE marking probability ramp into this two-stage format, some of SE's benefits can be realized without realizing multiple queues. There are some compromises in the performance. The current implementation is not knob-free. You have to configure the level at which that kink in the graph appears. But SCE can coexist fairly with conventional traffic and with the same queuing parameters run smoothly in competition with itself. The ramp parameters are chosen at the single queue bottleneck node in question, which means that this is a network administration decision and doesn't need to be specially set up at the end nodes. And here is what happens when you have conventional and SCE traffic competing with this setup. It's not ideal, but you can see that SCE is getting more throughput than it did in the previous example. And then when we put two SCE flows together, you can see that they run smoothly for the most part. There's a little bit of a glitch at the end where probably a stray CE mark got in. But, you know, these are these sorts of things can be tweaked later with more experience. Now, a really important matter is that we have running code. In fact, we have multiple instances of running code. 4 months ago, at the end of IETF 104, we already had a FreeBSD sender, a FreeBSD receiver, and a Linux-based middle box. In fact, even two implementations there. Today, we have Linux senders as well, a Linux receiver with a better feedback algorithm, and we even have a FreeBSD middle box, thanks to this report that we got from Logan from Africa. So, our work continues to mature, diversify, and characterize all of our work. And as part of that, we found some interesting things about TCP pacing. First, something fundamental, which also I think applies to other high-fidelity congestion controls. That high-fidelity congestion signaling is very sensitive to burstiness of the traffic, because these bursts collect transiently in the queue and cause this congestion signaling. Clocking is not sufficient to avoid these bursts, especially when you have delayed ACKs, because delayed ACKs naturally lead to packet pairs. So pacing is effectively mandatory when used with high-fidelity congestion signaling. In connection with this, Linux actually exempts the first 10 packets in each flow from pacing. This is quite a misfeature. It prevents slow start from working with SCE, so we patched it out. It's a one-line fix. We also found that the transition from slow start to congestion avoidance requires a halving of the send rate. Normally, this is provided by the first congestion signal experienced by the flow, whether that's a loss or a CE mark. So what we have to do instead, because we don't have a multiplicative decrease all the time, we use modified pacing scale factors, which enforce a throughput change at that boundary. And we expect to continue experimenting with that. So, if we have also we have a public repository containing SCE code. It's based on the Linux 5.1 NetNext series kernel. And I forgot to put the URL on the slide, but
you can send us revised slides and we'll happily post them.
I'm sure we can. We'll post a link on the mailing list as well.
Sounds good.
Please do post. Sorry,
Okay.
first.
Corey?
Please do post where we can get the patches or whatever you're working on. I guess they weren't upstreamed. The changes you're talking weren't upstreamed. They were your own versions, yes?
We have a complete Git repository.
Okay, excellent. Post that, please. Now, my question is, accurate ECN is something you've been working on here as well. How does accurate ECN figure with what you're doing? Because you seem to be reusing other bits.
Well, AccuCN takes over the NS bit for the three-way handshake, and if its negotiation is successful. We found that AccuCN was not actually useful for our purpose, so we declined the AccuCN negotiation and used the NS bit thereafter, as if it were nonce-sum, essentially. The reason why AccuCN was not useful to us is because the 3-bit field it produces counts CE marks, which we already have perfectly adequate feedback with the RSC 3168. But what we need is feedback of the ECT1 code point.
Yeah, got it.
Which is provided only by the TCP option in AccuCN.
Right.
And TCP options have their own problems.
Yeah. And previously, ECT0 to ECT1 was a non-normal transition, which we didn't engineer to when we did accurate ECN, I guess, because that's not expected in the internet.
This is true, and so of course we will need experimental status in order to formalize this as an experiment. However, we believe it's mostly harmless.
Andrew McGregor. I'm quite concerned about your notes about pacing and the requirement to space packets out in that manner, because that says to me that this is going to interact extremely poorly with an aggregating MAC. If you end up dropping a few packets into the same MAC, aggregate, for example, as Wi-Fi, the access point is congested, so there's gaps between aggregates. Effectively, the network rebursts the traffic for you, and that's going to end up behaving poorly, because if you don't land in the same aggregate, you minimize the performance of the Wi-Fi.
This is something we have recognized, and something we will need to explore reasonably soon, probably.
And the other thing is, I observe we have two proposals for how to do something quite similar, who are using radically different evaluation methods and different congestion controls in all the experiments. Please, use the full matrix in both cases, because otherwise we can't evaluate.
Mia Kulevind. So first, two quick comments on accurate ECN. While I know that the discussion about this should actually go to the TCPM working group, but one big part about accurate ECN was compared to what data center TCP, for example, is using, that accurate ECN actually has a negotiation phase, so you know for sure that the other end is supporting it. That was a very important point. And the other point was also that the assumption is, if you use the ETC1 code point and the option is not available, which you can test for, then you need to opt out of that experiment eventually, while that mechanism still ensures that the traditional signal is feedback accordingly. So that's kind of the assumption for all experiments we do, and with the assumption also that maybe this whole option problem becomes better in future, and then you can use it everywhere. So it's a deployment thing. Yeah.
I'm sure that's something we can have a discussion about.
In TCPM, yes. I have rather a couple of questions because like listening to your presentation and looking at the diagrams, a little bit the message I got was that what you propose works very well with fair queuing, while you don't have any guarantees that there will be fair queuing deployed or whatever. However, if you use it without fair queuing, it's more a scavenger approach, and then you presented that you can be more aggressive, but then it looked to me that the more aggressive part also means that you get like more queuing delay, which is not the perfect that you're looking for. So for me, a little bit the conclusion was this only works well with fair queuing. Is that the message you can agree to, or is that not what you wanted to say?
You may notice that of the diagrams in this slide deck, only one of them used fair queuing.
Yeah, but like the other graphs didn't show to me the benefits you wanted to achieve. So I understand that it doesn't crash the system, but it doesn't really shows any benefit to me.
Well, you might look at the total throughput of this scenario, until it glitches, of course.
Something happens.
The glitch is a CE mark.
Basically, we eliminate the sawtooth and we get better throughput.
Yeah.
And
so, but that's only if everything would be using SCE, right? The previous graph you showed.
Again, this is something.
It's either you use fair queuing or everything in the whole world has to use SCE on your bottleneck. That's like the two cases where it's really beneficial.
Well, it still works even if there's boxes in the network that don't understand SCE at all. It's still safe to use.
Yeah, I understood that part.
I mean, if you have a network that internally wishes to use SCE for an optimization, then it can deploy SCE without requiring the rest of the internet to also deploy SCE or FQ or anything like that. I think that's important.
Can I make, John, can I make one point? If you could go to the graph with the Reno SCE versus Cubic single queue with SCE marking where we have the threshold set. Just to make the point that this is 80 milliseconds, so the throughputs you're seeing there are what you might expect anyway between Cubic and Reno. Just to make that point, if you look at it and you say, oh, it doesn't look fair, that's part of what's going on here is you're talking about Cubic versus Reno at 80 milliseconds anyway.
Quick administrative announcement. Mic lines are closed, and if people want to stick around, I think we'll try to fit in the multipath DCCP presentation at the end. So if we could keep Q&A quick here, that would help all concerned.
So, Richard Jeffenegger. I've read the drafts, and I'm still missing the kind of the problem statement and the space that you were exploring in addressing the problems that you want to solve. So I'm not quite clear if the problems that you're trying to tackle here are universally applicable to the internet at large, including low latency environments. And that's one part. The other comment that I want to make is it has a feel that the use of the NS bit or former NS bit feels to me like you're jumping at a solution or a signaling mechanism that is readily available without first evaluating if that would be the best option available. Because one observation that I think I've made is SCE and also in the accurate ECN / data center TCP environment, the normal CE mark both have a much less severe marking semantic than regular CE. So I was wondering, what are really the differences between SCE versus the L4S architecture with accurate ECN marking? Because from my point of view, it seems that the signaling aspects are really a secondary problem and shouldn't be on the forefront. We should discuss first what type of problem you want to address.
The I'm sure we can address those in a future version of the document. But I'd like to draw your attention to the last line on this slide, where we have the unambiguous signaling semantics on the different code points. So we can implement DC-TCP without leaving it unsafe for general use.
To be a little more pointed, there was a chart that went up during Bob's presentation about what happens when you run a RFC 3168 AQM on a set of traffic, some of which is using TCP CE marks, some of which is using DC TCP CE marks, and there are problems there. And what Jonathan's basically saying is that for SCE, CE means CE, CRFC 3168, and therefore you can't get into that particular problem scenario.
Okay. Right. I just wanted to agree with Miria. This is trading off some of the. This proposal appears to trade off some of the performance, particularly the latency performance proposed for L4S in order to gain some safety. And so that's really to me, that's an interesting question of consensus to consider. Like, how bad is the safety effect, particularly with regard to the 3168 interactions, and that's what I would like to see most discussed on the list, as well as conditions of sort of malicious use in its various scenarios in the admission control.
Okay, Jake, I take the comment that there's a different trade-off here, and we need to talk about that on the list. Also, we should note that there is also the ABE proposal to use the same code point, which is now RFC status, which we need to coexist with. So this doesn't take a free code point, it reuses a code point which we recently standardized, but we can do lots of things here. Please use the list to discuss this. We'll take one last comment and then we'll decide on what to do.
Yeah, mostly an administrative thing. The drafts, or not the drafts, the code repository is cited in the test draft. For anybody looking for it, it's actually in the drafts. It's in the test draft. And the other one, there is a missing implementation that was not in the slides, that there's actually a hardware implementation of SCE running today in 25 gigabit switching gear.
Thank you.
Yeah, and we learned about that actually today, and the reports are that it achieves far below a millisecond of RTT with big improvements in the link level retries needed to support whatever that application is. Yeah. So that's a big result for us.
All right. Okay. Thank you very much, and I would like to thank everybody who's worked on and contributed to both the L4S and SCE work and all the hackathon work. I think a very interesting, productive week has been transpired. Okay, we are over time, so I think we probably get to formally close the meeting here. However, if you're interested in MultiPath DCCP, we're going to go ahead and have that presentation. Marcus, are you here? Ah, okay, cool. Oh, to present that. So let's give people about 30 seconds so those who wish to exit for whatever reason can, and then we'll go ahead and for those who are interested, let's talk about something completely different, MultiPath DCCP. All right, I got to go find the slides here. Just a minute. Hang on a minute, I need to do one more thing. Where is it? There it is. I'm going to go click on that. Okay, cool.
So just to clarify, the TSVWG meeting has formally finished. This presentation we would have included. They will get agenda time next IETF. And since the room is not currently needing to be vacated, we will let them proceed to tell people what's going on, and maybe you get an insight into this new topic. If the Secretariat come in and tells we have to leave, then you'll be cut immediately.
Fair enough. So thanks for those staying around. My co-authors are not here anymore, so I'm Anna Brunström, and I will be presenting our work on multipath DCCP as a way of carrying UDP IP traffic over multi-connectivity networks. So a quick summary of the motivation. So we had Marcus from Deutsche Telekom had the first presentation of this as the previous IETF with a bit more details on the motivation. But we have multiple ongoing standardization efforts in other organizations. So in 5G, for 5G, 3GPP is standardizing the AT-SSS, steering, switching, and splitting. And you have in the broadband forum the hybrid access, which is for multi-connectivity networks. And they are using MPTCP to carry the TCP traffic, but there's really no solution for how to carry the UDP traffic. And for operators like Deutsche Telekom, they really see, the need to cater for both TCP and UDP if they're going to deploy any type of solutions for these multi-connectivity situations. And of course, with the increase of quick traffic that we may expect in the future, carrying UDP traffic could also get increasingly important. So the goal with this work is to look at the multipath solutions for carrying UDP traffic in this context, complementing MPTCP. And you can check out the last presentation, as I said, for some more details. So this is an overview of the MPDCCP framework. So you have a sender and the receiver. You have a virtual network interface that connects you to the IP on the other side, and then you have DCCP tunnels. You add sequencing information on top, similarly to MPTCP, and then you tunnel over the DCCP flows. So this is the basic architecture, and this was also discussed in the previous presentation. There are 3 drafts related to this: a draft on the multipath DCCP protocol, a draft on the framework, the overall framework, and the draft that maps the DCCP header into the UDP header so that you can get through networks, because DCCP is not generally passing through middle boxes. So these are the 3 drafts related to this ongoing work. We have worked since the last time quite a bit on the implementation and experiment side. So there is a prototype available inside the Linux kernel, unfortunately not open source at the moment. I know the Deutsche Telekom people are working on that internally. And then we also have a NS3 setup where you can evaluate the residential and mobile use cases. So the way this architecture or the setup looks is that we also have a number of scheduling components, because a key issue, of course, for carrying the multipath traffic here is how do you schedule over the different paths. And as compared to multipath TCP, when you carry UDP traffic, you also have the issue of what do you do at the receiver side in terms of resequencing. Do you let the UDP packets through? Do you make sure that some of it gets reordered, because you may now have different delays on the different paths that your traffic is going over? So we also have a number of different algorithms that we have looked on the reordering component of this framework. So what I wanted to do today is just to show you some short sample of those results that we have been working on. And in relation to the presentation last time, as I said, we've mainly been working on updating the implementation and on some measurements. There's been some smaller updates to all the drafts, improving on the language, spelling, things like that. For the multipath framework draft, there also the requirement section added. But in terms of the draft, we of course need to include some more detailed specification for the multipath protocol. We had some feedback regarding UDP options for the header conversion draft that needs to be taken into account, and also further aligning with the discussions in 3GPP and the broadband forum to make sure the requirements get right. But let's look at a few sample results. So this first one is from the NS3 simulations with UDP traffic, looking at what happens both for a switching and an aggregation scenario. And here we have a scheduler that prioritizes the Wi-Fi path as long as this path is available, and if not, it moves over to the LTE part. So in the top graph, it's the switching scenario. So then, as expected, here the path is has enough capacity to carry your traffic. So as expected, initially all the traffic goes over Wi-Fi. When the Wi-Fi disappears, it takes some time to detect this because we're now not using both the paths in aggregation mode. Once the loss of the Wi-Fi interface is detected, the traffic moves over to the LTE path, and once Wi-Fi come back, at the end moves back to the Wi-Fi path. On the lower graph here, you see what happens when you are in aggregation mode. So this also shows you one of the benefits of actually using aggregation or using splitting also for a flow that does not need the capacity all the time. But you see that when you have the Wi-Fi path quality going down before you lose the connectivity to Wi-Fi. So the scenario here is that you're moving. So you're in Wi-Fi coverage initially, and you're moving out of Wi-Fi coverage, and you're moving back into Wi-Fi coverage. And we can see that when we have the aggregation, then of course things go much more smoothly, because when your Wi-Fi path is getting worse, you're actually gradually shifting over the traffic over to the LTE path. And similarly, when Wi-Fi is coming back, it's smoothly going back over there. So this is kind of one of the goals with some of the initial experiments has also been to look at the difference between these different mechanisms, between just having the switching or having the splitting aggregation modes, and how that impacts performance. So this is just one of the examples from the NS3 simulations. Here is a second example that is from the testbed measurements. And this is also looking at the handover scenario in aggregation mode. And in the first scenario, we have a handover that is triggered similarly by this path that has the shortest RTT having the delay going up. And we're using a shortest RTT scheduler here. So what happens when the delay on the faster path increases, then the algorithm, as expected, moves over to the second path, which has a stable latency in this experiment. And to the right side, it's another handover scenario where you actually lose the connectivity on the cheapest path completely, and then you immediately switch over and traffic goes over the second path. So the two scenarios here are just two examples of different scenarios. One where you have a latency spike on the path, and the second one where you immediately lose the path. And this is also immediately visible to the protocol in this case. And as a third example, this module shows, this graph shows a bit also the impact of the reordering module on the receiver side. So what we look at here is the packet delay distribution. So the jitter in the, wrong button. The jitter that you see at the receiver side in the packets that arrive. And we now look at some different scheduling and reordering mechanisms. So the blue one here is just a dumb round robin or weighted round robin 80-20 share scheduler. And of course, then you will get a lot of delay differences in the packets that you receive. If you use some more better scheduler, like the shortest round trip time first, or even better, the OTS, which is a scheduler that tries to also take into account how long it takes to send your packets over a path, the queuing in the send buffer, trying to equalize the arrivals. You get, as expected, less reordering, but of course the most efficient is if you also have some reordering component on the receiver side, and in this case, it's using one of the adaptive reordering mechanisms that we have been playing with. Yes, Jake?
Jake Holland, I just wanted to report that on Jabber, Meetecho is reporting that they may have to disconnect the remote participation shortly. Their equipment needs to come down, even though the room is still.
I think she has one more slide, and then we can wind this up.
Yes. So let me move on to the conclusion then. So this was just a quick showing you some of the results that we have. So we now have prototype implementation, and also some NS3 simulations to test things out. And some of the first experiments look quite good. So we have tested both the switching and aggregation scenarios. We've also done some measurements with congestion controlled UDP flows running NADA, the congestion control for real-time media that is being worked on in RMCAT on top. And then, of course, things get more complicated and more interesting. So that part needs a bit more work. And one issue here is how these things will relate to 3GPP and how we can get some of these solutions into 3GPP in time. And my colleagues at Deutsche Telekom is having lots of discussions with other operators and vendors how to approach this whole problem space. And we will try and continue working on the drafts, and happy to receive any feedback. We have also the drafts up on GitHub, so you can make pull requests, you can send us mails or any comments. And you also have on this slide a link for a paper that we have recently put together, which has some more detailed experiment results. There was a presentation material for ICCRG that has a bit more results available. And also the previous presentation at TSVWG for more background information. So thanks to everyone for sticking around.
Okay. Thank you very much. Apologies that we wound up doing this. Clearly, we're going to ask for more time in Singapore, and we'll get you a better agenda slot in Singapore. All right, I think we're done.
I believe the Secretariat wished to dismantle the room, so if you could leave, that would help them. Pity.